Good afternoon, everyone. If there's one message I would like you to take away from this talk, is that evals can become a source of joy. Yeah. If you consolidate your agent's tools into an MCP server. Okay, I'll explain more. Okay. I'm Scott Yak from Datadog. What does Datadog do? Right. So Datadog is an observability platform. So you send us metrics, traces, logs, and this nice telemetry data. We provide the tools to help you figure out whether your service is running as expected, whether there's an outage, and how do you fix it. Okay. So we have a nice website. You can look at the metrics, check on your service. There's a nice dashboard to get an overall sense of how your website is doing, some traffic information. We have some really fancy tools to visualize how your service is running. So this is all very nice, but it's a bit intimidating for newcomers. And we don't just want you to know, to see what's going on with your service. We want you to be able to act with your service. So Datadog builds a bunch of agents, and we have learned a couple of lessons along the way. What we learned is that in the process from going from demo quality to production-ready agents, when you want to improve the scores so that you can actually accomplish the tasks, you have to deal with a whole bunch of failure modes. Things like hallucination, output formatting, tool call failures, and so on and so forth, right? And the answer that everyone's going to tell you is that you need evals, right? And I agree with that. You definitely need evals. But they're also a real pain, right? So I'd like to help with that, right? Evals are still going to be painful, but at least we can take away some part of it, tool call failures. And that's where MCP servers can help. Now, what are MCP servers? So without MCP servers, what you have to do is that for every single agent that you build, you typically have to build the tools to connect to the backend. And what usually happens is that because each agent is doing different things, they need different tools, they call the tools differently, and they expect different things from the tools. The tool calls fail in different ways. And that means that each agent team have their own tool call failure evals. And that leads to a lot of duplication of effort. What MCP servers allow you to do is that you can consolidate all your tools into one server. And so these tools can serve a whole bunch of different agent teams. But you could always have done that, right? But what's so special about MCP servers? Well, the nice thing is that MCP servers can also be remote. So not only are they just a building block towards or stepping stone towards better agents, they also talk directly to the customers. So your IDEs like Cursor can use your tools directly. Third-party agents like Cloud Code can use your tools directly and to build an agentic experience directly from the customer. So what this means is that your tools are no longer just a stepping stone. It's itself a product. And when you have a product, you want to come up with a good product experience. And what we want to get out of this product is that for our users, when they connect to our MCP server, their agents become Datadog power users. So to give you a quick sense of what it's like to connect to our MCP server, so here's the tab, the agent tab from Cursor, right? So you might ask you a question, like, are there any HTTP errors in service MCP, blah, blah, blah. Okay, then Cursor is going to talk to the LM, give you some feedback, and then it makes a tool call to our search logs tool. It chooses search logs. Then the search logs tool gives back the results, and then it summarizes what it found. Yes, I found some HTTP errors. Great, right? It is acting like a power user. As a user, you didn't really need to know Datadog search log syntax. It's good. So let's see what actually is going on in there so we have a better sense of what our MCP server actually needs to do. So here, what just happened, you have the user, you have the agent here, which is a Cloud Code agent panel. You have the MCP server, our Datadog MCP server, and there's our backend that serves the search logs tool and in the back. So the agent has a really important job, which is to manage the context window. It starts with the system prompt, and it makes a call to MCP server to list tools. so that it can fill its context window with the tool descriptions, and that way it knows what tools are available and how to call them. Then it receives the request from the user, and it adds that to the context window. It then calls the LLM to decide to see what to do next. It may decide to call a tool, and because of the information from tool descriptions. And then it makes a call to the MCP server. The MCP server takes that request, decides what to do with it. Maybe it calls a particular backend, maybe it calls that other backend. The backend returns the results, and the MCP server does some other business logic. Maybe it does some filtering, maybe it does some pagination, maybe it post-processes some JSON into a CSV, whatnot, right? Or error handling. And before it passes back the response to the agent. So now the MCP server, gives back the response to the agent. The agent loads it back to the context window. Now it's part of the context window when it decides what to do next. It might decide that it needs to do something, it still needs to go back and ask more questions. So it keeps looping until it's complete. And then when it's complete, it gives you back the result. Yes, I found something, and returns it back to the user. So that's the flow of the agentic system, or a most basic agent loop. So I often get this question, what exactly is there to do in MCP server? Don't you just wrap around the API and you prompt the tools, and prompt the tool descriptions, all that stuff? So yes, the tool descriptions is an important part, right? It tells the agent how to call tools and what tools are available. But besides that, it's also important to note that the tool call response also gets fed into the agent context window, and that affects what we will do next. And so in the MCP server, we control the MCP server, and because we are in the same company, we also can talk to the people who work on the back end to influence what comes back out of the tool call response. So that means that we also want to optimize the tool implementations. So this is a massive search space, right? It's not just the text in the tool description, it is the code base of your entire backend as well, including your MCP server. And how do you optimize that? How do you know what to prioritize? For that, you need evals. Right? And the thing is that so evals for MCP servers are different because there's a lot we don't control. When you're an agent, you control almost everything. When you're an MCP server, you control almost nothing. And that feeds into our eval philosophy. We don't optimize for any particular agent. We are agent agnostic. And we only check the final result, so we don't care about which tool it calls. Okay. So I'll go into more detail about why we choose this as our philosophy for evals. So why agent agnostic, right? And the reason for that is really because of helplessness. We don't really know enough about the agent, which agent needs to use us, so we cannot actually optimize for any agent. A different way to look at it is that we want our MCP server to be ergonomic enough so that any agent can use it well, not just the smart ones. The nice side effect of that is that you actually can prioritize simple agents. And what that means is that our evals, we don't need to use the expensive ones. We use the cheaper ones. We use the faster ones. And that means that our evals are fast and cheap to run. That's nice. Nice bonus. So why tool agnostic though? So what often happens when people make tool call evals for agents is that when the agent reaches a particular step, they will say, okay, make sure you call this tool, and make sure you call this tool this way. And I think there's a better approach than that. And the reason is that agents are creative. Like, there are often a few ways to solve the same problem. For example, if you want to check which service went out of memory, there are probably three tools in Datadog that can give you that answer. But if you were to force a tool to say, okay, you have to call search logs, then the agent goes ahead and tries something else, then the evals are going to fail needlessly, and you have too much stuff to add into your evals. It becomes brittle. And the other thing is that agents are surprisingly resourceful. So one thing that I've accidentally noticed when I was using Cursor with our MCP server is that sometimes once I misspelled a service name, it actually zoomed out. So it added some wildcard tags, it removed certain filters, so it effectively is zooming out, and then it sees, okay, what service names are in your logs in the first place, and it finds one that is actually similar enough to the service name that you had, and then it zooms into that and says, okay, we didn't find the exact thing you want, but this is probably what you want. Like if you are in some very tight agentic loop with very rigid evals, you're probably going to mark that as a failure. But if you are a human trying to do something, messing things up once in a while, that's actually a nice experience. So we don't want to erase that by overly rigid evals. And the other thing is that because we are the team that develops the MCP server, we want to keep upgrading our tools. If we make it too hard to change our tools, then when we want to do big changes, big improvements, like consolidating 5 tools to 3 tools, like switching to a different query syntax or adding one tool that just makes all tools better. If you have overly rigid tool evals, that is going to prevent you from making those changes in a way that you can see the eval scores before and after, right? Because once you change your tool surface, you have to rewrite your evals, and you don't get an apples-to-apples comparison anymore, right? Your tool-specific evals become too brittle, it becomes change detectors, and you don't want that. You want to keep improving your MCP server so that when you connect to it, the whole experience is just better. The user shouldn't have to think about the individual tools. And the effect of that is that our eval runs are fast, right? From the time you change your code and you run the eval run, and you see it in the dashboard, it takes only 2 minutes. We run it locally. It's nice. When you see it on the dashboard, it looks like this. We have it instrumented with Datadog LLM observability. And so you can see at a glance, right, which tool calls failed, which tool calls succeeded. And then you can zoom into that, one of those scenarios, and say, okay, like show me the spans of the tool calls, the LLM calls, and all that happened. And then each of these things have a trace ID, which you can then take the URL, copy it, put it into your group Slack, and see, hey, this thing failed. Why did it fail? Can you help me take a look? It's a very nice debugging experience. So it makes running evals actually fun. Like you change something, you rerun the evals, 2 minutes later, you see stuff you can share with your team. You try something new that makes something that didn't work before work. You can now take this trace ID, share with your team. Our evals now become integrated into the dev cycle of our MCP server. And now devs want to write evals, right? If they are trying to do something with an MCP server that is challenging its existing capabilities, and the evals don't actually capture that new possibility, they want to write an eval so that they can see, hey, before this failed, now this passed. I did something great. Now, how does this help agent builders? So the nice side effect for other people is that tool call failures are now handled by a central team. So the agent builders, they don't have to handle tool call failures with their big end-to-end eval runs, right? So tool call failures are handled by this lightweight process that's done by a small central team. This means less work for them. And another good side effect is that, let's say you have a few agent teams, and one of the agent teams gives you some feedback that, hey, this tool doesn't really work very well, maybe you didn't describe it properly. So the feedback from your agent team can lead to MCP server improvements from your developers, and that leads to improvements to all your agents because now they are using the same MCP server with the improved tooling. That's very motivating for people who are building MCP servers. So it was nice to run the MCP server, but how do you make the eval scenarios to run in the first place, right? Running eval scenarios was never really the hard part. The hard part is making the eval scenarios, right? I just told you how to do the easy stuff, but not how to do the hard stuff, right? So let's go through step by step. How do you actually make a single eval scenario for an MCP server? So first, we think, okay, if you are a Datadog Power user, you should know how to search for logs. You should understand log search syntax, right? So you look at the documentation page, you see, okay, we need to understand how to put tags, service tags, basic things, okay? So show me recent logs in a service name full. Simple question, reasonable request. Right? Can you make that an eval scenario? So the unfortunate thing here is that if you call this thing, your actual answer is a whole blob of JSON, right? And if you want to put that in, if you put that into your evals, it's going to be all very verbal, so you don't want that. Actually, you can just ask it for counts because you're trying to test whether it understands the log search syntax. Right? If it knows how to make a count and it gets back a specific number, chances are it actually knows how to call that. It actually understands the syntax. Just changing from counts to lists is pretty trivial. So can we make this the eval case? Not yet, because the word recent is ambiguous. So we need to make this more specific. Right? Recent could mean 15 minutes before, it could mean 5 minutes before, right? It's not like a different LLM call might decide that it means different things, and you get a different answer. So this needs to be made unambiguous, right? Is this okay now? Still not yet, because last hour depends on what time you're calling it. So now you need to fix the time. There's this little thing called time travel, which you can pass in a timestamp into your server, and the server pretends what time it is now. And now finally, this is actually unambiguous. You can, as a human, or you can get a script to help you generate this, get this answer, put this in the eval scenario, and then no matter when you run it, you're going to get back the same answer as long as the two calls are correct, right? And it also doesn't really matter if your MCP server, if your LLM makes a different call to a different tool, or you change your tool surface and you just get back the same answer. It's fine. It's still going to pass. So how many evals do we need to make? So let's go back to our documentation, right? So we have wildcards. We have 2 wildcards. We have full tags. We have free tags. We have all this special syntax. We have all these edge cases that we need to deal with. Right? So we need maybe hundreds of eval scenarios just to cover search logs. And then we have other products too. Not only do we have logs, we also have metrics. We have traces, right? And then not only do you want to make a query on one thing, you want to make queries across different products. And how do you do that? How many evals do you need now? Maybe thousands, right? And that's going to be several days on nonstop groundwork just to create eval scenarios. And what's worse is that if you work for a company that has data retention limits for your logs, then every time the data disappears, you have to repeat this whole process all over again. Because once the data disappears, your new data comes in, then last hour and your now time needs to change, and the answers are all going to change, so you need to do this all over again. So is there a better way? The good news is that you can actually generate those evals. You don't have to do this by hand. It's a bit unintuitive that this is actually possible, so I'll walk you through that. So if you start with the question, a natural language question, and you try to get the answer, this is not really easy, right? If you're just using a simple agent that tries to make a tool call, this is not easy. That's why we're trying to make agents in the first place. But if you start from a C query, you kind of know what the answer should look like, and then you turn that from the C query to the answer. That's easy. You just pass that query exactly into your API call, and then you can make a script that just gets that answer. And then to go from the C query to the question, it's not so straightforward, but what you can do is that you can use a parser, parse this thing, convert it into an AST, and then from the AST, you traverse the tree. For each node, you map it to a text template, and that will lead you to a natural language string that preserves the semantic meaning of that C query. So this does not involve an LLM. This is a straightforward, you can write Python to do this thing for you. How do you get a C query in the first place? Right, we just made the problem, we just passed the problem to another place. So here is where the LLM or the coding agent comes in. The coding agent, with the help of a product documentation yeah? Hello, anyone? Okay. All right, so with the help of your coding agent and your product documentation and some elbow grease, because your coding agent is going to look at the placeholder service names. What's going on? You're going to look at the placeholder service names and just fill in, say, API. But it doesn't exist, right? You work for this company, you know what services actually exist. So you have to fill in, say, from service API to service full, right? So you still have to do that. But you can generate a whole bunch of C queries at once. And with those C queries, repeat that for each process. for each question, for each query to get a question answer pair, and then zip them up to get labeled eval scenarios. So these labeled eval scenarios, you can put them all into a Python list, and you can all run them locally. So we just went from one docs page to 200-something eval scenarios. That's pretty nice. But we now have a new problem. Too many evals, too many eval scenarios, right? If you just, so the first thing to do that you probably would do is that you print them to your console log because we're running it locally. But then when you have 200 eval scenarios, and before your change, you got 0.7 as a score, as average score. After the change, you got 0.71 as an eval score. So was this a no-op, or was it because something improved and something got worse? At a glance, it's not easy to see. But what we can do then is, going back to the previous example, you can use your LLM to also help you add some tags. Because when you use that process, you were referring to the product documentation, and the product documentation probably has some sections, headers that tell you what capability it refers to. So you can add the capability tag. Then you can pass these tags along to your instrumentation to pass into your spans that you pass to LLM observability or your favorite observability tool. Then you can group them by capability. So at a glance, you can see what capabilities you're doing well at and what capabilities you're not doing so well at. So here, we can see that count with CIDR has the lowest average metric score. And so we should probably do something about that. So as a human, you look at this thing and you think, okay, I probably need to tune the prompts for my log search syntax so that I know how to deal with the CIDR. Maybe I didn't think about that when I was writing the tool. Or you can ask Cloud Code to look at that and help you optimize it. Because by instrumenting this thing and putting it into LLM observability being a Datadog product is also can be exposed through our MCP server. So now you can ask a coding agent like Cloud Code to point to it and to ask some information. So let's start with just running the evaluation, right? We got the score of like 0.04, a low score, we want to improve that. So then we can ask the coding agent to analyze the evaluation result with the help of our MCP tool for like LLM observability tool in our MCP server. So it analyzes this thing. And now that this analysis is in the context window of the coding agent, you can point the coding agent at the piece of code that you want to optimize. So in the next slide, you're looking at the code at a diff. Like the red part is looking at the tool description for our MCP server for search Datadog logs. And the red part is the one that is what it's going to delete, and the green part is what it's going to improve. It's going to add. Right? You can see that it is trying to deal with these IP addresses now. So you can optimize the code and then restart the server and then rerun the evaluation and get a higher score. So you can repeat this process again. And that's the self-optimization loop. So to recap what I just showed you, so we generated 200-something labeled eval scenarios. You can run evals locally in 2 minutes. You can visualize results on the dashboard. You can analyze the failure patterns on a dashboard, or you can do it with the help of a coding agent. And you can point the code at the place where you want to optimize, whether be it the business logic, be it the prompt, the tool description, or somewhere deeper in the backend to optimize the code based on what we just put into the context window. So as a recap, there's a huge search space that we can optimize by being as like MCP server developers. And with all these automatically generated evals, they can become a source of joy, not just for MCP server developers, but also for all the agent builders that build on top of our MCP server. But the first thing you have to do is to consolidate your agent's tools into an MCP server. Thank you.
Thank you, Scott. We have time for 2 questions.
Very nice presentation. Thank you very much. I'm wondering if you are experimenting also in fixing the issues that Datadog finds in a similar manner using MCP server, then feeding that to Cloud Code and then fixing the issue automatically.
Wait, can you repeat what are you feeding into the thing?
Basically, how you are fixing the evals. You can also use MCP server for Datadog to see the issues that Datadog found and then automatically fix by using MCP server and Cloud Code.
Yeah.
And are you experimenting with this or?
I definitely plan to. Yeah, this is some of this stuff is vibe coded. It happened in a pretty short amount of time.
Okay, yeah, we are looking forward. We are users and it's just amazing tool. Thanks.
Thank you.
Thank you. We've got time for one more if anyone has a question. Yeah, okay.
You mentioned at a point where you need the backend to return different type of response so that agent can handle them better.
Okay.
Can you be more specific?
Yes. So the thing is that our tool surface is not the same as our API surface, right? When you have an API, people expect it to be stable, right? People build code on it. They don't change it very much. Every time you change the API, you break anyone who hasn't updated their binaries. But with MCP, you can change your tool description every time because they're going to have to call the list services every time they restart they initialize and restart their agent. So you can actually, it's more forgiving. You can change your tool surface more often. So what we can do is that we can actually have a different API. We can have a different interface compared to our API. So for example, what we can do is that we can do some spelling correction. We can do some checking before it reaches the API call. We can perhaps, if we think that this is a clustering query instead of a list query, we can actually just call the clustering API instead of calling the list API.